So this is like the question we did in class. So we've got a square, m is the midpoint, so that means that, let's get my calligraphy brush, right? That means that this is a half and this is a half. BC, Q splits BC in a ratio of 1 to 3. So this is quarter and this is 3/4. AC and MQ meet at the point P in the center. We're told that OA, the vector is A, and OC, the vector is C. So we've got to express OP. And OP, remember, is from the origin to the point P in terms of A and C. Right, so there's no direct way to do it. So how can we do this? Well, if I want to go from O to P, how can I get there? I can go from O to M, and then I can go from M to P. That's one way of doing it. And I could go from to O to P. I could also go from O to A, and then I could go from A to P. Okay. Now both of these rely on the diagonals. Okay, so let's have a look. So let's look at M to Q. So M to Q, I could get there because I know what OM is. Right. Okay, so from M to Q, if I want to do that for that diagonal, I'm going to go from M to O, and I'm going to go from O to C, and then I'm going to go from C to Q. So how do I do that? Right, so I'm going to go M to O is minus half A. I'm going in the opposite direction. O to C is easy, that's C. And then C to Q is 3/4 of A. Okay, because remember these now that's basically, remember this is using the fact that that basically both sides are parallel, so the vectors are the same. Right, so I've got MQ. Now let's type that up. That means that MQ is equal to 1/2 A, which is I've got minus a half plus, oh sorry, 1/4 A, because I've got minus a half and plus 3/4, so I've got 1/4 A, and I've got 1C. Right, so now I've got that. Okay, how about A to C, the other diagonal? So A to C, how do I get there? Well, I'm going to go A to O. I'm going to go O to C. So now A to O, that's easy, that's minus A. O to C, again, that's easy, it's just C. So now I've got two ways of getting from O to P. So let's write those down. So my first way, I've got O to P is equal to O to M, as we said. Okay, and now I've got to do M to P, but P lies on MQ. So M to P is actually somewhere along the line M to Q. And now I know what M to Q is because we worked that out over here. So that means that it's equal to O to M, which is a half of A. Let's just write that. That's a half of A plus lambda times MQ. So lambda times MQ, which we said was 1/4 A plus C. Now our second equation, O to P, as we said before, was O to A And then P lies on AC. We don't know where. So we're going to do lambda times A to C. So now that means I've got O to A. That's just A plus mu times AC. And we said AC was minus A plus C. Okay, so now I've got two ways of writing the same thing, but we end up in the same place, so they have to be equal. So let's write them as a single equation. So I've got a half A, and I'm adding a lambda times a quarter A. So I'll rewrite this all together. So I've got a half A plus lambda times C plus a quarter A. And that's equal to A plus mu times C minus A. Now, like we said, in class, this is like partial fractions. I'm going to basically equate my coefficients. So imagine if I factor out A. If I factor out A, I will have A times something equals A times something. Right, so we've got A times. So we've got A times a half plus A times a quarter times mu. So that means I've got a quarter mu. On this side, I've got an A, and then I've got mu times negative A. So actually that means I've got A times 1 minus mu. So now I can make those equal to each other because we're equating coefficients. So that means that I've got a half plus a quarter mu equals 1 minus mu. Right. Okay. That's one equation. I need two because I need a simultaneous equation. So let's look at B. If I factorize out B, sorry, C. So for the first one, we're going to have C times something equals C times something. So on this side, it's easy. I've just got mu times C. So that's mu. On the other side, I've got lambda times C. So that's lambda. So that means that lambda equals mu. So that's our second equation. Lambda equals mu. Right, now what I'll do is use the simultaneous equations. Now remember, simple simultaneous equations, if I add them together, mu and negative mu means they're going to cancel each other out. So I'm going to add these two equations together. Okay, so I've got a half. I've got lambda plus another quarter lambda. So with your brilliant fractions, you know it's 5 over 4 lambda. I've got 1, and now I've got mu plus negative mu cancel each other out. So now I've got that. So let's take away a half from each side. 5/4 of lambda is a half. So therefore, lambda equals 2 over 5. And if lambda equals 2 over 5, remember I said our other equation was that lambda equals mu. So that equals mu. So now we know lambda, now we know mu. So now all that remains for us to do is to go back and write that equation in terms of A and C. So OP, let's do number 2 because number 2 is slightly easier, a bit less work. So we know that it equals A plus 2/5 of C minus A. So I've got 1 whole A, take away 2/5, so I've got 3/5 A plus 2/5 C. And that is the final answer for A. Right, I hope that makes sense. that covers all the important stuff that we covered in the lessons today. Okay, that we're using scalars, and then we're using a simultaneous equation to find out what the scalars are.